So in this video we are going to see how to find the center of gravity of the composite plane figure. Let us assume this is a L section, the dimension is 20 millimeter and this breadth is 40 millimeter and the height is 60 millimeter. Okay, right. So we are all know the centroidal distance x bar and y bar of the composite plane figure. That is, x bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2 and so on. Similarly, y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2. So for simplify this, we have divided this L section into two parts, either this or like this. So let us assume this is the portion 1 and this is the portion 2. So here x bar is equal to, here of course we have a two plane figure, both are rectangular plane figure. So the area a1 x1 plus a2 x2 divided by a1 a2, then y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2. So here we need to find the necessary value, that is a1 is this. If the data is not given, you are seeing the same value, 20 into 60, that value is 1200 millimeters square. Again a2 is equal to, you subtract this value, whatever the value assumed here is 20 millimeter. So 40 minus 20, 20. So 20 into 20, that is 20, and this 20 is 400 millimeter square. Similarly, x1 is the horizontal centroidal distance of this plane figure. You assume that the centroid G for this plane figure 1 is taken as this distance. So let us assume this distance is x1. So x1 is half of this value. What about this? This is, we assume 20 millimeter. So x1 is equal to 20 divided by 2, which is equal to 10 millimeter. Similarly, x2 is the horizontal central distance of the plane figure from this. Okay, so from this point you read the value, because this is the reference axis. X and y is the reference axis. Here in this big problem, I am assumed the bottommost is the horizontal reference axis and extreme left edge is considered as a vertical reference axis. So you should read the value from here. Here 20 plus half of this. Again this is 20. So 20 plus 20 by 2, that is equal to 30 millimeter is the value of x2. And y1 is vertical centroidal distance. I mean from bottommost reference axis to the actual centroidal. This is y1. y1 equal to 60 divided by 2, which is equal to 30 millimeter. And similarly, this is our y2. y2 is equal to half of this, 20 divided by 2, that is equal to 10 millimeter. Now you apply this value here. X bar is equal to a1 value 1200 into x1 value 10 plus a2 is 400 into x2 value is 30 divided by 1200 plus 400. So you can find this value in terms of millimeter. And y bar is equal to a1 1200 into y1 value 30 plus a2 value 400 into y2 value 10 divided by 1200 plus 400 and find the value of y bar in terms of millimeter. Now based on this value, here the value for x bar is equal to 11.67 and y bar is equal to 21.67. Let us mark the centroidal axis in the actual plane figure. So x bar is equal to, you read towards x from the reference axis. So you assume that this is a 10 and 11 means above this. Okay, and y bar is 21, just above this point, because this is 20, that should be above this line. So this is xx and this is our yy. This is a horizontal central axis and this is the vertical central axis. This distance is x bar and this distance is y bar. I mean the distance from the reference axis. X bar, y bar is the centroidal distance of the plane figure with the reference axis.